Hello everyone, and welcome back to the channel. In the previous tutorials, we imported airfoil coordinates into DesignModeler and SpaceClaim. But in this video, I'll show you how to import the same airfoil coordinates directly into ANSYS ICEM CFD and prepare the geometry for meshing. We'll use the famous NACA 2412 airfoil as an example, but this method works for any airfoil coordinate file. Remember we downloaded the NACA 2412 data from airfoil.tools before? So to save time, I'll skip that part and we'll jump straight into converting the file into an ICEM-compatible format. There are two ways to import airfoil coordinates into ICEM. The first method is to import only the points using this range of cells. The second method is to import both the curve and the points using this block of data over here. Let's start with the first method, importing the points. Copy this range of cells and paste it into a new Notepad file. Now, open ANSYS Workbench. From the Component Systems toolbox, drag and drop an ICEM CFD component into the project schematic. Right-click on the ICEM CFD component and select Edit. Before we import the coordinates, we need to make sure the units are set correctly. Go to Settings, select Model/Units from the top menu. Choose millimeters as the length unit and click Apply. Click OK or Dismiss to close the welcome window. Next, go to the File menu, select Import Geometry, and then choose Formatted Point Data. Select the text file you just created, click Open, and finally, click Apply. As you can see, the points have been imported successfully. Now zoom in on the trailing edge. From the Geometry menu, select Create/Modify Curve. Uncheck the Inherited Part option. Click the first option on the left, From Points, to create a curve from the imported points. Select the two end points at the trailing edge and create a line between them. Then click Apply or simply press the middle mouse button. Next, continue creating the airfoil profile by clicking each point in sequence until the curve is complete. Go to the Parts branch. Right-click on Parts and select Create Parts. You can name it whatever you want, but make sure the name is descriptive and easy to identify. For example, we can name it airfoil_curve. Now click Select Entities, then select the trailing edge line and the airfoil curve as separate parts, and press the middle mouse button to apply. After deleting the geometry part, you'll have both the points and the airfoil curve as separate parts. The other format imports both the points and the curves. The only difference is that the first column specifies the number of points and the number of curves. In this example, we have 35 points and 2 curves, the upper curve and the lower curve. Now, simply copy the data and paste it into a new text file. Go to the File menu, select Import Geometry, and then choose Formatted Point Data. Open the file and click Apply. As you can see, the points and curves have been imported successfully. If you zoom in on the trailing edge, you'll notice that it is open. To close it, uncheck Inherited Part and draw a line connecting the two endpoints. Next, in the Parts branch, right-click on Curves and select Add to Part. Select the trailing edge line and press the middle mouse button to apply the operation. Now, the entire airfoil is grouped into a single curve part, while the points remain in a separate points part. Unfortunately, you can't create a 3D extrusion directly from a simple airfoil profile in ICEM CFD. In ICEM CFD, there are two different types of extrusion, and many beginners confuse them. On the left is mesh extrude. This method starts with a 2D meshed surface. After generating the surface mesh, you extrude it to create a 3D volume mesh, such as hexahedral, prism, or tetrahedral elements. So if you only have geometry and no mesh, this method cannot be used. On the right is blocking extrude. This works in the blocking environment, where you extrude 2D blocks to create a 3D structured blocking topology. Here, you're not extruding an existing mesh. Instead, you're building the block structure that will later be used for structured meshing.
The key difference is simple. Mesh extrude extends an existing mesh to create volume elements. Blocking extrude extends blocking topology to build a structured mesh framework. So, if your model is only a CAD surface, you'll first need to generate a surface mesh before using mesh extrude. But if you're creating a structured hexahedral mesh with blocking, you'll use blocking extrude instead. Understanding this distinction can save you a lot of confusion when working in ICEM CFD. And that's it for this tutorial. I really hope you found it helpful. If you enjoyed the video, please give it a thumbs up and subscribe to the channel for more ANSYS tutorials. If you have any questions or suggestions, feel free to leave them in the comments below. I read all of them. Thanks for watching, and I'll see you in the next video. Take care.